Hello and welcome to another video. Today I'm carrying on with my exam paper series. I'm going to do a GCSE maths paper back from June 2018 and I'm going to be focusing on a paper 3 today, paper 3 higher. This is going to be taken from the AQA past exam paper series and I'm only going to be doing a half paper, so I'm going to be doing the even questions. Attached to in the link to this in the description to this video, you will find a link that will take you to a Google Drive where you can download a copy of this paper. If you've not already got a copy of it, I would recommend you download that now. And you do the paper either before or alongside the video, just to get the most out of it and to push yourself a little bit. I'd also recommend having some music on in the background just to make the video a bit more enjoyable. I record these with an earpod in, so I have some music on in the background. If you find this video useful, please do subscribe and turn on notifications, and whenever I drop a new video, you'll get a notification. Before we get into the paper, I'm just going to bring up the question level analysis for this paper. So this paper, I've taken the even questions from the paper 3, and this is out of 41 marks. So slightly more in this than in the odd paper that I'll produce at a later date. And this gives you rough grade boundaries for this paper. So the grade 9 was pretty high here. We were looking for 47 out of 37, which is pretty high. And you can see the other grade boundaries just so that you have an idea of what mark you're aiming for on this paper. The other useful thing here is the questions facilitated by grade. So that tells you roughly how easily accessible each of these questions are. Obviously, the lower the percentage, the more challenging students found this. So it looks like on this paper, question 20, Algebra and Pythagoras was the most difficult one found on average by students, just to give you some idea as we go through. Okay, let's start the paper then. Okay, so this is the paper. I've just taken the paper, I've cut all the odd questions out and produced it and put a QR code on the front. Other than that, it's the same as the AQA paper. I'm going to be using this Casio FX emulator for my calculator section when I need it. If you've got a different one, I'll talk you through basic functions if there's anything particularly different. Right, let's crack on with question 1 then. So, not question 1, question 2. Circle the list of all integers that satisfy x is greater than -2 but less than 4. So we want to start at -1 and we want to go up to and including -4. So that's going to be, let's get my pen out. That's going to be this option here. Okay, question 4. What is the size of the exterior angle of a regular decagon? Well, a decagon is 10-sided, so it's going to be 360 divided by 10, so we're looking at 36. Right, question 6. A and B are similar shapes. B is an enlargement of A with a scale factor of 1.5. Work out the values of x, h, and w. Well, x is going to stay the same because an enlargement won't change the size of the angle. So that's going to be 54. H, this side here, is going to be 1.5 bigger. So I'm going to do 5 times by 1.5, which would give me 7.5. And then W is going to be equal to 9 divided by 1.5. Which is going to give me 6. I'll put those answers there as well. 7.5 there, 6 there. Okay, question 8. Show that the line y is equal to 3x plus 7 and 2y minus 6x is equal to 8 are parallel. So for them to be parallel, their gradients must be the same. So I'm going to say m must equal 3 for both. In form y equals mx plus c. Shouldn't really have gone into that, but there we go. Right, so I'm going to look at the second line because we've already got the gradient here. So for the second line, if I start with 2y minus 6x is equal to 8. If I rearrange this, then minus 6x from both sides would give me 2y is equal to 6x plus 8, and then divide both sides by 2. I would get y is equal to 3x plus 8. So parallel as both gradient 3. Right, part B. Is the point minus 5 minus 6 is the point above, below, or on the line of y is equal to 3x plus 7? What I'm going to do is I'm going to say that y is equal to 3 times by minus 5 plus 7, which would give me minus 15 plus 7, which would give me the coordinate minus 8. So the coordinate would actually be minus 5 minus 8. And if we think about roughly that line, so we've got positive gradient, positive intercept. We have got the point minus 5 minus 8. Minus 5 minus 8. And we're asking about the coordinate minus 5 minus 6. So it would be above. Right, question 10. The nth term of a sequence is 12n minus 5. Work out the numbers in the sequence. The numbers in the sequence that have 2 digits and are not prime. Okay. So I think I'm going to list it. So to do that, I'm going to use the table function on my calculator. To do that, I'm going to go menu, and then I want to go into the table function, which I think is 9 on this. No. A bit unfamiliar with this. There we go. Yeah, 9. So the function of x I'm going to type in is 12x minus 5. I want to start. I don't need a second function, so I want to start at 1. I'm going to go up to, let's just think about it. If it was 10, 120, 10 is going to be way too big. So I'll go, let's say 9. And I want to go in steps of 1. So I'm going to go 7, 19, 31, 43. Let's get some more values. 53, 55, 67, 79, 91. Right, now I'm going to get rid of all my numbers that are, well, I'll get rid of that one because it's got, these numbers have got to have 2 digits. And I also want not prime. From the list, not prime, prime, not prime, 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 and not prime. So I'm looking at 55 and 91. Okay, question 12. Pressure is equal to force divided by area. A force of 40 newtons is applied to an area of 3.2 meters squared. Work out the pressure. Give a unit for your answer. Pressure is equal to the force, which is 40, divided by the area, which is 3.2. So that's going to give me, so let's go back into 40. I'll do it as it appears. 3.2 equals 12.5. And my unit here is newtons per meter squared. So I'm going to go newtons per meter squared. Okay, question 14. Draw the graph of y is equal to 0.8 to the power x for the values of 0 to 6. Okay, so again, I'm going to use that table function on my calculator. So the function of x this time is 0.8 to the power of, for x, and I want don't need a second function, I want my starting range to be 0, my end point to be 6, and I want to go in steps of 1, so that's going to be my table. So 0, 1, 1, 0.8, 2, 0.64, 0.512, 0.4096, and then I've got 0.3276, and then finally 0.2621. Isn't very good. 0.2621. Right, and let's try and plot that then. So my first coordinate is at 0, 1. Second point is at 1, 0.9, 0.8, sorry, and then 2, 0.64, so these are going up in 2s. 3 and 0.512, so just above 5. 4 and 0.409, so 5 and 0.327, so, and then finally 6 and 0.2626 is going to be there, so just above there. Then I do it with as smooth a curve as I can, not point to point, we're after a curve. So that's not very good. Let me try that again. These aren't very easy to draw on a screen. It's still coming out wavy. I think I've got it on that one. Right, a bit wobbly, but that's about as good as I'm going to get on the screen, I'm afraid. But hopefully that makes sense. Okay, question 16. Two straight lines intersect at point A. Circle the coordinates of point A. So it is the intersection of minus 4x, 3, so where they're equal. So x is going to be equal to minus 3 over 4. So we're looking at the coordinate minus 3 over 4 and 3, which is looking like that. Okay, question 18. Show that for x not being equal to 0, x plus 4 divided by 3x minus 5 over 2x can be written in the form ax plus b over cx, where a, b, and c are integers. Okay, right, so I'm going to put them over a common denominator of 3x. To do that, I need to times the first one, not 3x, sorry. I'm going to put them over a common denominator of 6x. To do that, I'd need to times the first fraction by 2, so that would become 2 lots of x plus 4 minus, I'd need to times the second one by 3, so 5 times 3 would be 15. So multiply it and then tidy up. So that's going to give me 2x plus 8 minus 15 all over 6x. So that's going to be 2x minus 7 over 6x. Right, question 20. So all dimensions are in centimeters. Use Pythagoras' theorem to work out the exact value of x over y. Okay, so Pythagoras' theorem is that x squared plus 7x squared is equal to 10y squared. So that's going to give me x squared plus 49x squared is equal to 100 y squared. So I've got 50x squared is equal to 100y squared. So if I rearrange this a little bit, I want x over y, so I'm going to start with x squared over y squared. So x squared over y squared is going to be equal to 100 over 50. So that's going to be x squared over, I'm actually going to put that in a bracket, is going to be equal to 2. So x over y is going to be equal to root 2. And I'm going to leave it like root 2. I could go decimal, but root 2 is fine. Okay, question 22. A, B, C are points on a circle. A, B, C, yeah. D, C, B is a straight line. P, A, Q is tangent to the circle. Sam is trying to work out the size of angle M. Here is his working. Angle ABC is equal to 56. ABC is equal to 56. Angles at the same segment are equal. Okay, make a criticism of his working. So that's angles in the same segment are equal. That's incorrect. That's incorrect. It's not angles in the same segment are equal. It's angles, it's alternate segment are equal. So make one criticism with his working. It is alternate segment, not same segment. Not same. Is everything else right? I think everything else is right, but it does say make a criticism. That's the criticism I'm making. Okay, 24. The speed time graph shows 20 seconds of a car journey. So we've got 20 seconds of a car journey. Harry wants to estimate the distance the car travels in this time. He uses a triangle and a trapezium to as shown to estimate the area under the curve, under the graph. Okay. Complete Harry's method to estimate the distance the car travels. Okay, so we're looking at the area is going to be equal to half of the base of this triangle, which is 10, times by the height of this triangle, which is 20. To that, we want to add the area of the trapezium, which is going to be a half of A plus B. So 20 plus 30 times by 10. So I need to make sure I type this in right. We've got quite a complicated sum. So a half of 10 times 20 plus a half of 20 plus 30 times by 10. So if I've typed that incorrectly, I get 350. I might need to double check that. Right, let's check my measurements. 10 and 20, so 10 times 20. Yep, that looks fine. Plus a half of 20 plus 30, that looks fine, times by 10. Yeah, that looks fine. Right, question 24b. For this journey, which of these is true for Harry's method? It is an overestimate, it is an underestimate, it could work out as an overestimate or an underestimate. So we've missed off this. We've missed off that from the estimate, so it's going to be an underestimate. Okay, 26. The histogram shows information about the speed of cars as they pass a checkpoint. The scale on the frequency density axis is missing. The histogram shows information about 480 cars. How many cars does the first bar represent? Okay. So the area is going to represent the frequency. So I'm going to try and take, rather than overcomplicating this, what we can actually say is if you look, we've got a 1 by 3 here, and actually we've got 3 by 1s here, so that area would fit there. So we can do it by counting the squares. So we've got 3 by 2, 4, 5, so we've got 15 squares there, 15, 16, 17, 18, 19, 20, 21. 1, 2, 3, 4, 5, 6 squares there. And then if we add these 3 little strips here, we would have another 3 squares. So we've got a total of 15. So actually that's 9. So we've got 15 out of 24. Yeah, 15 out of 24 times by, so that's the area of the whole. And if the whole represented 480, that will tell us how many cars the first bar represents. So 15 out of 24, that's the fraction of the area that we're after out of the whole, and that the whole would be 480, so 480, so we're looking at 300. So 300. Okay, part B. Cars with a speed greater than 40 miles per hour are over the speed limit. Use the histogram to estimate the number of cars that are above that speed limit. Okay, so that's slightly more awkward. So we want 2/3 of whatever this bar is. So if we think about it, so if we said that this is 300, this is a width of 5, 10, 15. So 300 divided by 15 is 20. So that must mean that we're going up in jumps of 4s. So right, 4, 8, and 20. That's not a particularly nice number. Yeah, so if that's 20, this is going up in fours, which isn't a particularly nice thing. But what I'm going to do is I'm going to say that the area of that is, work it out and pretending that that's 1. So the area of that, if that was 1, that would be 0.8. So 0.8 times by 10. 0.8 times by 10. And then actually we want it to be a 1 there instead of a 4. So we'd need to times, we want it to be a 4 there instead of a 1. So we need to times that value by 4. And that'll give us the number of cars that have gone over 40. I think that's probably the most straightforward way of doing it. So 0.8 times by 10 times by 4 would give you 32. And there are other ways that you could do it, but I think that's probably the most direct and straightforward. Okay, 28. So P is a point on a circle with equation x squared plus y squared equals 80. P has an x coordinate of 4 and is below the x-axis. Work out the equation of the tangent to the circle at P. Okay, right. So this is quite an awkward one. So I'm just planning it in my head. So I want the full coordinate of P. I can say that that's going to be at a right angle with that to find the gradient of that line. So I'm going to start by working out the coordinate of P. So it has an x coordinate of 4. So 4 squared plus y squared is equal to 80. So y squared is going to be equal to 80 divided by 16, which is going to be plus or minus 5. Get a bit more. Yeah. And we've been told that it's the negative version, so it's minus 5. So the coordinate of P is going to be 4 minus 5. From there, I want to work out the gradient between that and 0, 0. So the gradient of OP, so I'm going to go OP gradient is going to be equal to the change in y divided by the change in x. So that's going to be minus 5 over 4. So let me just check that I'm happy with that. Change in x divided by change in y, so minus 5 over 4. Yeah, so the gradient of the equation of the tangent, so the gradient of the tangent is going to be the reciprocal of that, negative reciprocal, so 4 over 5. So y is going to be equal to 4/5 of x plus c. And we need to use the coordinate 4 minus 5 to work out the intercept. So minus 5 is going to be equal to 16 over 5 plus c. So c is going to be equal to, I want to do minus 5 minus 16 over 5. So that's not a very nice one. Minus 41 over 5. So yeah, I've just looked through. I've made a mistake here. So I'm going to have to, my method's fine, but I've made a mistake here. So I'm going to have to go back. So let's get rid of this for now. Right. Apologies about that. So it should have been 80 minus 16. 80 minus 16, not 80 divided by 16. Right, 80 minus 16 is going to give me 64, and then the square root of 64 is going to be 8. So plus or minus 8. So that should have been minus 8. Right, so the gradient of that then is going to be minus 8 over 4, which is going to be minus 2. So the gradient of that would actually be 2. There we go. So I'm looking at 2. So that's going to be a half, sorry, not 2. So y is equal to a half x plus c. Y is equal to a half x plus c. And then plugging in my values, my coordinate is 4 minus 8. So y is equal to minus 8 when x is equal to 4. So that's going to be 2. So that would be minus 10. So c is minus 10. Meaning that the equation of my line then is y is equal to a half x minus 10. There we go, that's better. Okay, so that brings us to the end of the paper. Before I sign off on the video, I'm going to just bring up that question level analysis again. Okay, so again, there's the question level analysis for that paper. So hopefully you're able to total up your score and see how you would compare on that. And also the chapter links within this video take you directly are referenced to the topics that they are. So if you struggled on a particular area, you can do some independent study on that. I do have a number of just revision videos as well as these exam paper walkthroughs. If you can't find the topic you're after, though, let me know. I'll try and put one together for you. I hope you found that useful. Again, if you have, please do subscribe if you like and turn your notifications on. And as soon as another video drops, you'll get a notification. Thanks very much for your time in listening to the video. Please add any comments, questions, or feedbacks into the chat. I'll get back to you fairly quickly on that. Hope the rest of your revision goes well, and I'll see you soon.